Hi, my name is Tori Morgan, and this is the third video of the Global Sensitivity Uncertainty Analysis series. So we've already created our fact file in the first video, and then we created our matrix file, or our SAM file, in the second video. And so now we're going to add these files to a file sharing platform and organize the files so that they can be run on the hypercomputer. So I am using FileZilla as my file sharing platform, but you can use whatever file sharing platform you desire. You log in with the host, username, and your password's your UFID password. I believe the host is your username at hpg.rc.ufl.edu, and then your password is your GatorLink account. And the nice thing about FileZilla is once you've gone on once, you can just do a quick connect. And it logs you back on. And you can always refresh right here. So now I want to show you the files that you need in these folders. So you should have already downloaded your class folder. So for me, it's 2018 class_GSA. And so the first file is your class folder, and in this folder you need your makejobs.sh. This should have already been in the folder, and it helps the hypercomputer create the jobs. You also need the matrix.txt folder that we created in the second video. I have a different name for it because I run multiple models with the GSUA, and so I want them all to be slightly different. So I'll show in the code, in case you have a different name, how to convert it to a file that can be read as a matrix.txt file. And then you also need your fact file in this folder, and that was a file created in the first video. And then you need your job.top and job.bottom GSA files in this folder. So if you remember Dr. Carpena's explanation of this, it is like a sandwich where the top and the bottom are the bread of the sandwich. And once you run the model and create your jobs, it's going to have a bunch of outdone files that are the vegetables and meat of the sandwich that go inside of it. So your top and bottom help sandwich all of that together. And then next is your bin folder. This just has all the Unix utilities that are needed in order to run the model in the hypercomputer used in SENS class. This is just copied directly from the folder when you downloaded it. So there's not anything that we have to modify in our bin folder. And then we have our base folder, and this is a really important folder. It has the SENS class, which should have already been downloaded. But then there are a few files that we need to create before we can run our model on the hypercomputer. So you see we have this par.txt, inputs.dat.ptr, and inputs.dat.ori. And then your inputs.dat file is just the file that you created when you created your model in Java. It should have read from this file, inputs.dat. And it works with your jar file. So you should also have your jar file in the space folder. So your muttons and gluttons.jar, I have my own model in this folder. So now to create the files, you can open up some type of text editing platform. And so you see I have 7 inputs for my inputs.dat. The inputs that are read into my model, and some of them will be varied and some of them won't, as I mentioned in previous videos. Your inputs.dat.ori is just a copy of these inputs. It's your original inputs file. And then your par.txt are only the inputs that change within your model. So if some of your inputs stay constant, then you do not include them in the par.txt. So I have 5 inputs that are varying and being distributed through the model.
And then your inputs.dat.ptr are all of the inputs and their names, similar to the par.txt format, except for you also include the inputs that stay constant. So you saw I have 7 inputs here, 7 inputs here. This one only has 5 because 2 of them stay constant within the model. And then the inputs.dat.ptr has all 7 again. You have the names. It's in a name format for the inputs that are changing, but the inputs that stay constant, you keep as those numerical values. So the model will recognize the body weight and then change all of the inputs and distributions that were given for body weight, and then it'll come to this number and it'll keep it as 0.003. It won't vary that input. So this you should have already created. You copy those inputs into a new file like this, and then you name it inputs.dat.ori. And then you need to have the par.txt match the same order as the inputs.dat. So 18 corresponds to body weight. So then I write this as body weight right here. And similar with water concentration, ingestion rate, and so on and so forth. This one, again, matches it line by line, and especially in this one because it has all 7 inputs. And again, you keep the numerical values the same. So after you've created those files, you can upload them into your FileZilla or file sharing platform. So I have my files I created at ptr, par.txt, .ori, and now you're ready to run your code and check it in the terminal, which I will show you in the next video. Thanks for watching.